Here's the review for our next exam, Exam 2, the first part at least, and we begin with question 1. Question 1 asks us to determine the intervals on which this function x cubed over 3 minus 2x squared plus 3x is increasing, and those intervals on which it is decreasing. To do this, we want to start by taking the derivative of the function. We only need the power rule for this, so we bring the 3 around front. 3 multiplies by the first term, which is divided by 3, so 3 times a third is 1, so those 3's are gone. And then 3 minus 1 is 2, so our first term becomes x squared. Then for the second term, I bring the 2 around front here, multiply 2 times negative 2, that gives us negative 4. 2 minus 1 is 1, so this is negative 4x to the first, so there we have it. And the second term, negative 4x. And the 3x is a first degree term, and 1 minus 1 is 0, and anything raised to the 0 power is 1, so that's why for linear or first degree terms, we only they differentiate to the coefficient. So our derivative is x squared minus 4x plus 3. We need to find the zeros of that derivative, and so we set that derivative equal to 0 and solve. X squared minus 4x plus 3 easily factors as the binomial x minus 1 times the binomial x minus 3, and those show that our zeros will then be at positive 1 and positive 3. On the sign chart here, we put we indicate that at 1 and 3 we have critical numbers, so that our derivative is 0 there, and then we check a value. We only need one value in each interval. So in the first interval I choose 0. It's easiest to evaluate the derivative at 0, and so I find f prime of 0, the value of the derivative at 0. Wherever I have an x, I put a set of parentheses, and in those parentheses I substitute 0. So 0 squared is 0, 4 times 0 is 0, and so the value of the derivative at 0 is 3. And of course we do evaluate the derivative at some point in this interval, not the function itself. We only evaluate the derivative because we want to know when the derivative is positive and when it's negative. Since it's positive for this one value in this interval, then it's going to be positive for all. In this interval, 1 to 3, we choose 2. I evaluate the derivative here at 2. 2 squared, which is 4, minus 4 times 2, which is 8, plus 3. All that adds up to negative 1. So negative 1 is less than 0, and so on this entire interval from 1 to 3, the derivative is negative. And finally, in this interval, beyond x equals 3, I choose 4, and so that's 4 squared, which is 16, minus 4 times 4, which is 16, plus 3. And so 3 is the value of the derivative at 4. It says f of 2 and f of 4, but we know that it's f prime. And so 3 is greater than 0, which is positive, and so the derivative is positive on this entire interval. So that tells us that the function is increasing from negative infinity to 1 and 3 to infinity. And notice that we use the curved brackets there to indicate that 1 is not actually included, 3 is not actually included. Everything up to 1 and everything beyond 3 Well, it's also negative between 1 and 3, and so the function is decreasing on the open interval 1 to 3. Next, we go to question 2. And question 2 asks us to use either the first derivative or second derivative test to find any local extrema of this function. It's the same function, and because we have a sign chart here that we've already created, we can see that that the derivative changes from positive to negative at x equals 1, and so the function has a local maximum there. Now, to make sense of that, realize that a positive derivative means that the function is sloping up, it's increasing there, and just beyond that, right after where x equals 1, the derivative is negative, so it's sloping down, so we slope up and then down, and so that tells us we have a local maximum there. And then because the derivative changes from negative to positive at 3, we know that the function has a local minimum there. Now, to use the second derivative test, we take the second derivative of the function, and that first derivative was, we recall right here, x squared minus 4x plus 3. So we use the power rule to determine the second derivative. 2 comes around front. 2 times x is 2x, and this is a first degree term, so we just retain the coefficient, and so that's negative 4, so the second derivative is 2x minus 4. Now we then evaluate the second derivative at each of those critical numbers. F double prime of 1 is 2 times 1 minus 4, or negative 2. And f double prime of 3 is 2 times 3 minus 4, or positive 2. And because the second derivative is negative at x equals 1, the function has a local minimum at x equals 1, and because the second derivative is positive at x equals 3, the function has a local minimum at 3. Now, a negative derivative, or second derivative, indicates that the function is concave down. And so, of course, if it's concave down, then there's going to be a peak, and that's where our local maximum is. In the second instance, because the second derivative is positive, that indicates that it's concave up, and so that means that it's gonna bottom out at some point, and that point is x equals 3. So that's the first and the second derivative test. It's your choice, but that's finding your local maximum and minimum using the first or the second derivative. Doesn't matter which one you use at all.